Hello and welcome to a minitab 18 video for chapter 5. I'm going to be going over how to do some discrete probabilities and binomial probabilities today. If you have not watched the video on our lesson for today, I highly suggest you do that before watching our video for Minitab Express, just because some of the terminology I'm going to use today you will not be familiar with before I begin this video. And so it can make this one a little bit more confusing to watch. So the Word document you see on my right hand side of the screen is, well, what you've seen me, well, what you find above this video as a attachment. You'll notice I have Minitab open, but there's no data this week, and that would be because we're essentially just going to be using Minitab as a calculator this week to calculate some probabilities rather than to, you know, do some stuff to data, because all we're doing is calculating probabilities. I already said that. All right, that's awesome. So just to start off with today, I'm going to use an example from the lesson that was a little bit difficult to accomplish by hand. So we had done these calculations using the binomial formula. So what I'm going to show you how to do today is how to actually make Minitab do this for you. So I'm using the bank example where a bank believes that its customers prefer to bank early on Friday, but actually want them to be open on Saturday morning. So, sorry, prefer that they close on Friday early and then have a Saturday hours basically. And they have 8 customers they're going to randomly survey, and they want to do a binomial distribution of this. So they want to see what are the probabilities to make the probability distribution. So what I actually need to do is close my security that opened, is tell Minitab the values I want it to do for the binomial. So I'm going to go ahead in here and throw in all of my x values that I want it to do. So 0 through 8. Remember, the binomial is special because it actually starts at 0, which some distributions actually don't do, which is kind of fun. I always remember that because binomial has an O in it, and O for 0. I don't know if that helps you out, but it's one way to kind of remember that fact about it. So what I'm going to do is I'm going to use the calc menu to accomplish this. So I'm going to go to calc, down to probability distributions, and then you'll notice there's a big long list of distributions. We're only interested in the binomial today. So again, calc, probability distributions, binomial. All right, so I want some probabilities, not cumulative probabilities. Cumulative probabilities you want to use if you want to accumulate or add a bunch of them together. I just want single values. I just want to know what the value is for when x is 0, 1, 2, 3, 4, 5, 6, 7, and 8 individually. So I'm going to change this radial button to in probability. We will not do any inverse cumulative probabilities, so you don't have to worry about that last button. All right, now I need it to give some information. It wants to know the number of trials or how many times I'm going to repeat this. That's 8 because I have 8 customers. It wants my event probability. This is also considered the probability of success. That's that 80% that we have from earlier. And then we need to input a column. So this is telling it what values I want it to do. So I had inputted those into X earlier, and then it's going to ask me for what column I want to store these values in. Now this is optional. If you don't do this, then Minitab will produce a table of values for you in the session window, but I want to store them. So I think I'm going to put this in C2, just like right next to the X variable so that it outputs there. So this is going to make it output my probabilities in this column next to X. Let's go ahead and hit OK. And there are my values. So all I have to do is copy these and paste them into Word. And if I remember, this pastes terribly. Yep, okay. I hate tables in Word. They don't paste as well as what you would see. Yeah, there's no smart paste options either. That's kind of unfortunate. Okay, well, the same thing happened when I did this with Minitab Express. It pastes better in Excel if you like Excel. Unfortunately, the smart table options for Word are a little bit limited. What I want to show you is what would happen if I changed the option that I had there for optional storage. So I'm going to hit Edit Last Dialog to bring up the last thing I did. And I'm going to remove the optional storage option. So what it's going to do is then output them into the session window. And this actually looks a little bit better because I was hoping this would make it more like a table and it didn't. So there we go. And that will output it as a table. So what I'm going to just do is just delete this one from Word. Goodbye. And just paste my lovely table from Minitab. There we go. Merge list. Oh, I got it to enumerate it. I don't want that. So unpretty. But there we go. There's my probability distribution. Remember, distributions for probability models need to do the following. They need to tell you which values the variable could take on. So x can take on the values 0 through 8. And then what probability each of those values have. And that's the second part of the column. So for instance, if we look at the row for 4, this tells us the probability that I get 4 people out of my 8 that say that they want they want the bank to have Saturday morning hours is, just a little bit above 4%. Kind of small, not very likely. looks more likely I'm going to get 6, which makes sense because at 80% times 8, you should have about 6 or 7. It's like 6.5. Anyway, let's play the same game, but an example you haven't seen before so you can see how this is set up. Knowing how this is going to output, I'm going to delete the table. Alrighty. So we have inherited blood type here. If one of your parents is type O and the other person is type A, then each of their children has a probability of 25% chance to getting 2 O genes, which means they would have blood type O. Fun fact about inheritance. So if you are planning on having 5 children like my insane sister, then you can look at this and figure out how many or how likely it is that you're going to get a certain number of children in of your 5 that would have type O blood. So each child we're going to treat as inheriting independently from each other, as in each birth is independent and not related to each other, so that I can use that to fill this out. So I've already used C1 and C2, so I'm going to go over here into minitab and use a different one. So I'm going to just call this type O. Not type O as in I've made a mistake, but type O blood. And then what value could I possibly have out of my 5 children? It could be none that have type O blood. It could be 1. It could have 2, 3. We could have 4, or we could have 5. So I need this column first to be able to create my probability density function using minitab. Then I'm going to go up to calc and down to probability distributions, and then down to the binomial. Again, I still want probability. Here I only am going to have 5 trials because they're only going to have 5 kids. My chances have changed too. It's 25% chance of having type O blood. And my input column is different now, so I'm using the type O column to create my table this time. And let's go ahead and hit OK, and that will produce my blood type table. Let's copy and paste that into our document. Keep source formatting, I like that better. Move it over. There we go. Butamus. So you should look at this table and tell me, it appears it's most likely that for these people, only one of their 5 children will have a type O blood. Which makes sense. Because if you do 25% times 5, it's just a little bit bigger than 1, which that one's the highest. Might be 0, might be 2 though, because those are pretty high as well. Alrighty, so that's how you can build a probability distribution using minitab for the binomial setup only. Keep that in mind. If they're not using a binomial, if it's not a situation where you have a defined success and a defined failure, and all of your trials are independent, then you cannot use this. Oh, and you have to know the number of trials you're doing, otherwise you really can't do this. On to a fictitious and slightly silly example that will hopefully help you see how to do the binomial. So I'm going to use the binomial now to do some individual calculations of some probabilities. So back when I was in college, I had a friend in my chemistry class who hated all of our multiple choice quizzes, and we had them every single day, and that's inspired this example. So my friend was named Erin. This is not Professor Erin Simmons. This was a girl who did go on to end up changing her major and ended up getting a degree in theater, and she's quite an excellent actress. But she hated our chemistry class quite a lot, and she always guessed on our quizzes, never studied. It was not a great choice, but you know, let's pretend this is back in the day and we're going to try to teach her a lesson using probability. So the setup for these quizzes, there were always 10 questions, and each question only had 4 options for their different choices. So this scenario follows a binomial. Just in case you're not sure that it does follow a binomial, let's see how we can set up and see those pieces. So the first thing we have to assume is that Erin is just going to always Christmas tree it. She's going to guess. So her chances of getting a question right, also known as little p, oh, I hate it when it does that. I do not want you to autocorrect. So little p is going to be my probability of getting a question right. And since there's 4 options, it's going to be 1 out of 4, or also known as 25% or 0.25. What I'm going to be counting here for my x variable is the number she gets correct. So number of questions correct. And the last but not least, I'm going to note my n, my sample size, which it's going to correct to capital N. I want little n. Screw you, Word. I know what I'm doing. Anyway, so since she's going to be taking this quiz and it has 10 questions, and on each question she has the same chance of getting it right, the number of questions she'll be trying this on will be 10. This feels like a binomial. Each question we're going to assume is independent of the other, so more or less we're saying, well, when I look at the questions, there's not one single question that gives me a hint on the rest of them to where I could possibly get this more correct than previous. Alright, so I want to find the probability that Erin gets exactly 1 question correct. So for me, that is going to be the probability that x equals 1. And I'm going to show you a way to do this. The first way will be using the calc menu, and then later on I'm going to show you a second way to calculate this. So here we go. All right, so I'm going to go back to the calc menu, and I'm going to use probability distributions again, and I'm going to go down to the binomial. And I am just doing a single value here, but rather than doing a column, I'm just going to do an inputted constant. So I'm going to just do one value is what I'm telling Minitab. So for Erin, the number of trials is going to be 10. Her event probability is still 25% because there are 4 options for every question. I always hated it when multiple choices had like more than one answer that was possibly correct. That always screwed me up. So we're just going to assume one answer is one of the options is correct. And then I'm going to input my constant, which is just 1. And I'm not going to give it an output storage. I'm just going to have it display it for me. So we're going to hit OK. And there's my answer. Pretty simple, huh? A lot less work than what we were doing on the notes. So you kind of read this vertically. Little x is 1, so then when I read this next statement, it's the probability that my random variable x, aka the number of questions she gets correct, is little x, and little x was 1. So this is saying the number she gets correct is 1, and the probability of that happening is below it, so that's 18, a little bit bigger than 18%, so 0.187712. Once you're rounding with this one does provide more decimal places than what you might need, so just round carefully when you're inputting your answers into my stats lab. All right, let's do another one. So let's say we want to see what's the probability that Erin gets none of the questions correct, as in she fails miserably and sad times occur for her in her life. So we want to do the probability that x equals 0. So I'm going to use the edit last dialog box, since the only thing I'm changing is the value of x in this. And you're going to do that a lot in the homework because you'll have a lot of questions that repeat and have a lot of you using the same distribution more than once. So I'm going to hit the edit last dialog box and then change my 1 to a 0. So all I did was change the value of x, the value of inputted into Minitab that I want the value of for its probability. And I'll hit OK. And there's my probability. So you might look at this and say, this doesn't seem right, Professor. I am very suspicious on why this is much smaller. Why did it get teeny? Ooh, I've mistyped that. 1, 3, I missed a 3. Sorry about that. 3, 1, 3, 5. Well, you're right. I mean, it is smaller, and you might be against thinking that this is going to be what's going on. Think about what the, sorry, your instincts might be against what's actually happening. So when looking at a 10-question quiz that has a 1/4 chance of getting a question correct at random, you should look at this and be like, okay, if I'm trying 10 times and I'm going to be right 25% of the time, on average, I should get 2.5 questions correct. So the chances that you fail to do that should be below average. That's why this is a small probability, the probability of 0. 1 is slightly higher because it's closer to 2, but it's still not close to 2.5, which is the average, which is why this is so small. Which is interesting, isn't it? So the closer you are to the mean, the higher probability you're going to have with the binomial. So these are actually small because they're kind of far from average. That means that you didn't get the 2 correct, or 2.5 correct technically, that you expect to get. Thank you, expected value. So it didn't go as expected. All right. So let's move on to this one. So here I'm going to do the probability that Erin gets a most 4 questions correct. So when she looks at her probability, the chances that she manages to get this a good number is not very good. So at most would be 4 is the largest, but it could be smaller. So this means less than or equal to. So we're going to go to Insert, Symbols, and throw the less than or equal to in there. If you don't like going to hunt for the symbols, because I kind of hate it myself, you can just type like a less than sign and an equal to sign, or write less than or equal to. That works as well. So you can do this with the calc menu as well. If we go up to calc, we're just going to change some of our settings. So I'm going to go to probability distribution. Oh, I could have hit LS dialog. Oops. Binomial. So I'm still on Erin's scenario. I've got 10 tries, 25% chance of being right. But I want it to do 4 and everybody less than that. And that's when I'm going to want to choose cumulative probability. So the important part about this is that cumulative probability for the calc menu and this setup option will only do stuff less than or equal to. It doesn't do greater than or equal to, doesn't do just less than, doesn't do just greater than, it only does less than or equal to. So it only does things like scenario C. Let's go ahead and hit OK. And there's our answer. So you notice the symbology behind that. 2, 1, 8, 7, 3. Yay. So looking right here carefully at Minitab, you'll notice that it only does less than or equal to, and that's the only direction it goes. So this in C is fairly easy, but if you look at 5, you'll notice, oops, hello, we have a problem. This is going to be a bit of an issue. And this is where the other option on how to do this is going to shine. But I think I'm going to go ahead and see and also do it the other way. So you can see the other option on how to calculate this and confirm for yourself that the other option does do this correct. So there's a second menu in Minitab that will do probability calculations. Here we go. I actually prefer this one, but it's got some quirks, so you got to be careful with it. So we're going to go to Graph, Probability Distribution Plot. We're going to select View Probability. We're never going to use any of these other three, so you can just feel free to ignore them. Let's hit OK. We're going to change distribution to binomial because that's the one we're using. This is in alphabetical order, so you know he's going to have to scroll up to go find that guy. It's going to ask you for your number of trials. That's 10 because Aaron's doing 10 questions. Your probability of success is that chance of being right, or your little p, in one trial. And then we're going to go to shaded area. This is where this is going to get a little complicated. So binomial, 10 trials. My probability of success always goes here. Let's go to shaded area. So it's set on probability. I'm never going to use that for the binomial. We're going to go to X value. So you'll notice these little pictures, left tail, right tail, both tails, middle, and it's kind of shaded based on the direction it's going to go. If you look at C, I want 4 or less. So at most 4 questions. So 4 values less than it, like 3, 2, 1, 0. And those are stuff that lie to the left of 4 on the number line. So I'm going to want a left tail in this case. And then I'm going to tell it where I want it to start doing that tail, which is 4. All right, go ahead and hit OK. And you should see that you get the same value that you do if you had done this using the calc menu. So a couple things to notice about this setup with the graph. How it's doing the graph and calculating your area is it's doing calculating your probability. It's using area to calculate your probability. So each box is about 1 in width. So 1 times the height makes area. The height is the probability. So by shading these 5 red boxes, it's getting all the area that makes up 4, 3, 2, 1, and 0, which are the probabilities that you get 4, 3, 2, 1, or 0, which is the stuff that makes up less than or equal to 4, which is kind of fun. So in particular, the values always appear on the lower x-axis, and then they always write the probabilities in Minitab up above it. So let's just copy this graph over real quick, just as like, you know, an extra way to do this. It's really unnecessary to do this. You're writing the answer right here is fine. But it's kind of nice to have this in your notes so that when you look at it and compare your answer using the calc menu versus using the graph menu, you know how to do that. So the other thing to notice is that just like some of the other graphs we've seen, that this is a little bit interactive by hovering your mouse over places, you should see values, I'm scrolling up for a reason, you've seen before, like, oh, what happens if I hover over 1? Oh, look, there's a value for x equals 1, and if I do the same thing over position 0, yay, there it is again. So if you are doing some of your assignment and it's something that has multiple parts and you look ahead and you see, oh look, it's got, you know, less than or equal to, but I also need some of these other values, you can just use that hover feature to grab specific values off of the graph and Minitab. Like I can go grab 6 if I need it later, and other things like that. You can use the smart graph feature to grab some of that stuff if you need it. All right, let's move on to D, because we're almost done. Now, a downside to the calc menu that you might not realize is that it will not do situations like D or E very easily. Now, D is, I want at least 5 questions correct. So how I always remember it as at least is like, what would happen to me because I was short as a child on carnival rides. They were always like, you must be at least 5 feet tall to ride the ride, which meant if you were 5 feet tall, that was all grand and you could definitely get on and do carnival things. But if you were shorter, you couldn't get on the ride. So at least, I know people see least and think that means smaller, but at least actually means the smallest it can be is 5. So it's got to be greater than or equal to 5. So we're going to change this to match that mathematically. Where's my greater than or equal to? I always hate that these symbols move around. There we go. So that's the wrong way. Quickly, quickly. There we go. Greater than or equal to. At least 5. The smallest it is 5. So if you're thinking about where this is at on the number line, this would be this value here, 5, and everything higher than it, all the way up to wherever this goes, aka 10, which doesn't show up on this graph completely. So in particular, if you wanted to do this using calc, you'd have to rearrange it and do it as a subtraction because calc only does less than or equal to. So you could do this as, you know, not doing it, 1 minus stuff less than or equal to 4, because the stuff that would not be in here is 4, 3, 2, 1, and 0, so less than or equal to 4, which would be using this answer to do it. So that's one option, but we're going to pretend we didn't notice that and make Minitab do it for us. So I'm going to go back into Minitab. I'm going to hit Edit Last Dialog because I want to use the graph menu. I've got my setup with my binomial properly in here. We're going to hit shaded area, and now here I need to be careful. I know I want to do 5, but I got to make sure I choose the right direction. So since I want stuff greater than 5, like 6, 7, 8, 9, those are values that lie to the right on the number line from 5. So I'm going to be choosing a right tail, and then I'm going to hit OK. All right, and there's my value, and it's actually kind of small. So you should look at this and be like, hey, Aaron, you're probably going to fail this quiz because the chances of you getting, half or higher is very small. Just very, very, very tiny. Yikes. It's very, very small. Anyway, I don't know if she'd listen. Guess we'll find out next time on math drama involving chemistry students. Anyway. Alrighty. The other thing you can do on the graph option that the calc menu doesn't do is in between values. So in particular in E, we want to find the probability that Aaron gets between 6 and 8 questions correct on the 10 question quiz, including 6 and 8. And this part's very important, the including 6 and 8 part. So some of the questions I was doing in the example lesson this week, we were looking at cumulative probability and finding values in between for probabilities. And we did one that was 1 unit apart, which was fairly easy because you could just find the value in between them using cumulative probability and the cumulative probability tables if you like those. I don't like the tables as much. I think this is a little bit more interesting and fairly easy to do when you think about it and do it using Minitab. So the important thing is that I'm including 6 and 8. Obviously, if I didn't include 6 and 8, this would just be the stuff between 6 and 8, which would just be 7, and that's kind of silly. So I want between 6 and 8, including 6 and 8. So I'm just going to do some spacing here, set this up. I'm going to need some symbols. So I'm going to scroll up and just steal this one rather than doing insert because it kind of drives me crazy. La-da-da. Just cheating a little so it looks nice. All right, between 6 and 8. So we're going to do a middle. So we're going to go back to, well, I've hit Edit Last Dialog a couple times, so let's remind ourselves where this is at. We're going to go back to Graph, Probability Distribution Plot, View Probability. So it's like the VP of probability. I don't know, that's how I kind of dumbly remember it. I'm still doing a binomial. I'm still looking at the 10 questions. I'm still doing event probability as being she has a 1 in 4 chance of getting it right. Keep in mind, and when you change questions, you will have to change this. So if you go to a different question, it's like, oh, what's your chances of, getting the golden ticket and we're playing Willy Wonka and it's 3%, and then you're going to have to change your percentage and your number of trials. So if you're going to eat 100 candies until you get a golden ticket, that kind of thing. Anyway, that was a silly example. We're going to hit shaded area. So here I'm going to select middle. So you see how it's got 2 little X's and then a gray space in between. For some reason, my screen is much tinier. On other computers I've looked at, it's much larger when you look at that. So notice now you have 2 values. So I'm going to use 6 and 8. And this is a little trippy. You have to be careful with it. It's a little bit more picky than some of the other places. Whatever you pick for x1 has to be smaller than what you pick for x2. Notice how the x1 is to the left of the x2. You're supposed to know from looking at that it's shading from x1 to x2, which means x1 has to be smaller than x2. Let's hit OK. Yay, there's our value. So your chances of getting, between a D and a B is not very good. It's like smaller than 2%. This always does 4 decimal places as well, so be careful. If you know you're going to need more than 4 decimal places. Sometimes it does a little bit bigger when they're smaller. This one's doing 5. For D it did 5. You notice for a C it did not. You're going to have to include a few more. So the last thing I'm going to show you is a little trick on how to force this to do some other values. So I'm going to go back up to A or B. I don't know, whichever one I thought was more interesting. Let's do A. We wanted to shade the 1 block. So we've seen that I can do left, so I can do the left of 1, which would be that way. I can do the right of 1, which would be that way. But I want it to just do 1 in A. So you can kind of trick Minitab into doing 1 value using the middle. So I'm going to go up to Edit Last Dialog Box so that it's on middle still. And what I'm going to do is I'm going to trick it into doing middle by putting the same values in here. So it's doing less than or equal to x1 and less than or equal to x2. So it's saying I want the values in between, well, bigger than or equal to 1 and less than or equal to 1. Well, the only thing that does that is 1. So it's only going to give you 1. Watch this. It's kind of trippy. Ta-da! Isn't that kind of cool? So if you want a single value and you want to use the graph menu, all you have to do is select middle and just use the same value twice for both your x values. And that works. It'll give you just that value, which is kind of fun. So there you go. That's how you do the binomial using minitab. If you like the calc menu better, feel free to use it. You'll have to be a little careful because it only goes left when it comes to accumulation. So you might have to do a little bit of switcheroo subtraction times to get it to work. And you'll have to be careful with that, just like we were doing in our lesson for this week. And if you want, you can use the calc menu to do middles, lefts, and rights. So feel free to use minitab to calculate to your heart's delight.